Please.
All right, so last time we got, let's see, did we get to the point where we wrote the formula? Let's do a problem. And let me see if I remember if I redid the formula. Let's say I've got 82% of stat students understands, well, sure, why not? I'll be optimistic. Independence. It might be, anyway. And let's say I pick 42 stat students. Randomly choose. What's the probability that exactly 37 of them understand independence? So what can you identify up here already? Good. So what's N? 42. What's P and Q? What do those represent? Good, because P represents probability of success, and in this case I'm looking for people that understood, so that's the success. So that's 0.82. What's Q then? Because what's Q represent? The probability of failure. Not finding what I'm looking for. So remember, success could be a rabbit, squirrel, right? Could be a zombie, could be whatever. Doesn't have to be good. It just tells you what I'm looking for. Okay. So what's true about P and Q? They have to add to be 1. I like it. So you can always kind of double check yourself and make sure they do, because people come up with really neat numbers to put here. Just make sure whatever the shit you put down adds up to 1 at least, or else something went wrong. Also, I almost never am going to use the percent number, because that's not the number. 82% represents what number? 0.82. So a lot of you guys on the quiz, not a lot of guys, but some of you guys on the quiz, you left it as 70.1 instead of 0.701. And when you multiplied it out, you got 15,000 something for probability. So 15,000% chance. What? All right, sorry. That should bother you. When your answer is bigger than 1, that should bother you. If you can't see what you did wrong, at least cross through it and say, I know it shouldn't be this. At least do that. Right? Maybe I'll take off 1 less point and I'll be a happier person. What is this? Did I tell you what that number, what it goes for as a variable?
Choose. How many?
X. And it will be the choose part, how much I'm choosing. So X is the number of successes. So let's see, how do I set this up? The formula, probability of 37 successes is what? How do I do this? So how many people do I have? 42, and I want to choose how many to do something? 37. What does that piece of this thing accomplish? What does it tell me, that number by itself? How long the list would be. Right? And we know that would be the coefficient in front of P blah Q blah, right? Because that's how many of those I would have. So the next piece of this is the P blah Q blah. So how many successes? Well, we just said it. How many successes do I want? 37. So how many failures do I want? Huh? 5. Why? Because I've only got 42 people. I can't create people, right? Not instantaneously. You know, in the long run I could, but no. Bam. So what's always got to be true about those two exponents? They have to add to be the total, of course, because I'm breaking people into 2 groups. Those who do this and those who don't. Okay, I like it. Chickens the ass in. Okay. And then you just throw in the old calculator. Take a second and see if you can throw the old calculator. Anybody need to borrow a calculator? Maybe doing some stuff later, might as well do that. Sure, good. Whichever you prefer. What you guys think. If there's any like better. Oh, Jesus. Which one is it? Aw, Jeff. I'll wait. All right. Error. Will Robinson. One thing you got to be careful about is to make sure that you're not still down.
Oh yeah, that's right.
All right. Oh, look. See if I can make this comfortable for myself. All right. So, to do this, what do I got? I got 42. How do I get to choose? Math. Probability. Number 3. Choose. 42 choose. 37. Now right here, make sure that you come up out of there. Up. If you have the older calculator, it's going to have 42 NCR, all in the same thing, so that you can just hit times. It doesn't have subscripts and exponents. So let's see, times 0.82 to the, see how I'm upstairs now? 37, so I better come back down. Bam! Times 0.18 to the 5th. Okay, so that's what it should look like. And did I say this? Can somebody tell me, do you guys think this would be a big number?
Yes.
Yes, it will be. Big number. This will be really small. So big times small becomes normal, is the hope here. Right. So then we get this. Okay. How's everybody feeling so far? So every problem that needs that formula is going to feel very similar. They're going to give me a percentage that do this, the probability of something, a total number of people, and I want so many to do that thing. All right, well there's N, P, Q, X. I can put that shit in there. Maybe. And we together, I know it was mostly me pushing you, but hopefully you kind of agreed with all the steps that led us to this equation. We could see how it got put together. And this thing saves me from having to make the list. Let's just see real quick. I want to see how big 42 choose. What was it, 37? Yeah, you want to make a list 850,668 long? Yes, Mr. Wall. Can we do that? No? Yes? You understand? You agree with that? Okay. So that's the one place that Jeff, who normally is completely against the calculator, apparently, I'll show you how to get shortcuts. That's the one place I definitely just go right to the calculator for. It's built to count, so you might as well use it to count. As long as you understand what that number means. I don't care where we get it from, if you understand. Okay. So, let me do a couple of new things, and then I've got a handout for you guys to work on. Believe it or not. Right here, let me see what you guys think. Why should that be, I picked that number on purpose, or something close to this number. If I would have picked 1, It's probably like get exactly one person who understands. Why would that be a remarkably small probability? You could do this. What percentage of everybody, of all students, understand? Yes. 82%. 82% of students understand. So how many would you expect to understand from a group of 42 students?
Like closer to what you.
Yeah, how exactly would you get that? 82% of 42. Let me say exactly what we just said again. The expected value of the number of students who understand would be 82% of 42. Bless you. What's another name for expected value? EXP. What is it? Expected value is the mean. The mean is the expected value. Right? If you give me the average of something, that's the best guess.
Are we going to run into any problems that wouldn't give us the 37 number? We would have to find it on our own.
All right. There's one problem in the homework where it says there's a 10-question quiz, and you have to get 70% of them right to pass. So how many questions would you need to get right to pass? 7. 7 would be X then. So very infrequently would there be something where they don't just tell you what's the probability it's going to be 7 or 37, whatever. They got to give it to you. But there they gave you a way to get it. You'll see when you get there in the homework. Well, all right. So let's formalize what I just said. The expected value of the number of students. So the mean is the percentage times the number, right? That is the formula for the mean for a binomial situation. And I did say that word last time, right? Binomial is a binomial probability because there's two outcomes. That's the most kick-ass mean formula yet. I don't have a list of numbers and I have to add them all up and divide by n. That's the basic average. Or I don't have xp of x. I got to do x times p of x and then add them all up. Here I just give me n, give me p, multiply, done. So what do you get here? In this problem you get 0.82 times 42. What do you get, sir? 34.44?
Yep.
Nina. So when I was going to pick that number, I did that calculation in my head real quick. I estimated what it was, and I picked a number close to that. Why did I do that? Why did I do that? Well, if I do this, everybody cool with this, right? That's a new formula you can have sitting on your formula sheets. We still have to do what? We still have to get a formula for what's the other thing I need in general. I always need the mean and the standard deviation. There it is. So we're going to talk about that in a minute. What was I about to do? Oh yeah, that's right. So what if this would have been, like I said, 1? What if that would have been 1? Yes?
Or, what is that number, like, what does a mean in this type of context? Like, is it like...
So an average is always, if you do something many, many times, it's the value I expect after averaging all the results. So if you take a group of 42 people, and you do that many, many times, everybody with me? I would expect, what was it we just got, 34.44? So if I take a group of 42 people and I say, all right, how many of you understand the idea of independence? And I see what that number is. And then I go take another 42. How many of you, okay. And then I take another 42. How many? And then I do that a lot of times. If I average up all those numbers I got, it's going to approach 34.44, yeah. I like it. It's a good question. Kick ass. So average always means if you do something over and over again, what is the average of the results?
I was thinking that it was going to be like average probability. It's like the average amount of students.
The average amount of successes you would get each time you took 42 students. Yeah. I like it. I like it. Now, what if I would have said 1? We already know that this is going to come out to be very, very, this probability should be really, really small because it's very, very far away from the mean. That's the expected amount. Is this impossible? Of course not. What would the formula look like now?
42.
Take a minute and put that in the calculator. Let's see what happens. You don't have to put that first power in there, of course, but you can if you want to. All right, let's see if we can interpret what we get. Boom! What does that mean? Don't put 1.01 or something crazy, because that's bigger than 1. What does E negative 29 mean? Anybody know? Times 10 to the. So this is not 1 point. I'd have to move the decimal back 29 times. So once, and then 28 zeros. So it's not impossible, but it's freaky as shit. So for example, do you guys know, not necessarily a movie, but Aaron Brockovich? Do you know the story of the Ballad of Aaron Brockovich? No?
Yes.
Right. Well, this was a lady. No. It was about PG&E, California. They were doing some crazy shit, had some stuff going on in the water they shouldn't have. There were people getting cancer at a higher rate than normal. So the rate of cancer in those areas were not impossible, but they were really, really unlikely. So what's more likely then? That it just happened randomly, that there were a group of people that got cancer? No. What's more likely is something's causing them. Do you guys kind of see what I'm saying? This is sort of like part of somebody's evidence that they could present. It's not proof, but holy shit. It's like if your DNA matches the blood found at a crime scene, is that 100% accurate? No, but it's pretty much close enough. Holy shit, especially if there's other things that has you there, right? As long as the police department didn't contaminate. Well, anyway, so all kinds of weird shit could happen, we all know. All right, let me see. So that, everybody cool with what that means? That little E-do, so be careful. Let me think. So, oh yeah, all right. While this is still up here, I can't remember if I did this. What's the general formula for this? Well, what's 42? What's the symbol for that? What was the idea behind 42? N. What was the idea behind this? X. So, total of this many things, choose this many successes. So how many P's do you want? X. I want X successes. Damn, try to say that. 8 times 5. That. Now here's where things get a little weird. How did you get 41 here? You did N minus X. There you go. So like almost always, the formula has to be general. It looks worse than what we do in practice. This little bit always trips people up, but you know how to get that freaking number. It's just the rest. And that's how to write the rest in Mathish. Yes? The which one? That was from, all right. So if 82% understand, what percent don't? Bam. So P and Q have to be opposites. They have to make one. I like it. I like it. All right. We know enough now to do this. Here we go. Bold claim, Jeff. I know.